Now we're going to take this opportunity to revisit numeric data types, and we're going to have to go a little bit further into depth with the different types of numeric data types, because we need to be aware of their behaviors when we perform operations on them. The differences in data types will affect the outcome, the result that we get, so we've got to be aware of that in order to get an accurate result. So let's look at the whole number data types. Most commonly is int in the integer. Big int, same as int, it's just got a wider range. Small int, and there's even a tiny int. In practice, I've only ever seen or worked with ints and big ints, mostly ints. But if we work towards the number types that have decimals, money, as you can probably imagine, is used to contain currencies. It's accurate only up to a certain number of decimals, and it has a cool feature in that it can be formatted. The output of a money column can be formatted with a particular currency in that format, so that's pretty handy. Decimals and numerics. Decimal and numeric are actually effectively the same data type, and I've only ever worked with decimals. But we need to be aware of numerics, and that'll become clear as we go through the course. And floats, a different type of decimal. We'll explain the difference between these three in the next slide. So let's work through this table of the decimal data types. Right up the top there we've got money, that is accurate to 4 decimals, and there's an example, and if this was meant to represent Australian dollars or US dollars, that would be accurate to 1/100th of a cent. And when you're browsing the Object Explorer, you will see the column defined simply as money. Decimals get a little bit more elaborate. The definition of a decimal, if you're looking at an Object Explorer, it is the word decimal and then 2 numbers in brackets afterwards. The first one is the total digits that are stored in the decimal. So this is variable. The point I'm getting at is that decimal columns, no decimal column is exactly the same as the other. They can all be different. They can have a different number of these 2 factors here. The first one is the total digits stored in the entire number, and the second digit there in the definition is the digits to the right of the decimal. So let's say, for example, we wanted to define a decimal column that we had to store, say, up to 100, 3 numbers there at the front, and 6 decimals up to 6 decimal places. We would define that as decimal 96. Numerics, that works exactly the same as decimals. They will appear in the course of our coding, and that'll become clear later on. Floats are a little bit different. The definition is you only define one number, and that is the total number of digits stored to the right of the decimal. So if we wanted to represent this number here, we would have to define it as float 5. In terms of the number of digits to the left, that's actually determined by the total size of the float, which is 8 bytes. So basically you can have as many to the left of the decimal point as will be stored up to 8 bytes. So that's quite a lot there. Again, getting a little bit technical, but if ever you see the word float and a number next to it in Object Explorer, you know what that represents. So let's return to our little query involving order quantity and the sales order detail table, where we took order quantity, we multiplied it by 2 and got an expression for increased quantity. Now, I've been saying all the while that every physical column in a database, such as order quantity, has a data type. And if we go down to Object Explorer, we've seen the order quantity is defined as a small int. It's one of the whole number data types, and we've seen that in the column. It's all 1, 2, 3. They're whole numbers. There's no decimals. Now that's a physical native column in the database. What about a made-up expression column? What data type is that? Well, there's a clever way to find out. It's with a special function called SQL variant property, and I'm going to show you how to use it. So let's just put it on a new line here. Now before I type it, I'm just going to go to the Microsoft documentation webpage where SQL variant property is defined, and basically it accepts, that's its definition there. It accepts, that's its name, SQL variant property. It accepts 2 parameters. One is an expression, and another is the property about that expression that we want to find out. Now, there's a whole bunch of, there's a select number of them. One is the base type, and that's what we're going to use. We're going to put in base type as our property and see what is returned, and it will return one of these many data types within SQL Server. So let's just find out which one. Now I'm going to copy and paste this same expression here into the first parameter. And I'm going to find out the base type property. I'm going to call it our type and just see what gets returned. Check that out. The type of our little expression is int. Let's do a little bit more investigation here. So to actually see the elements that make up this increased quantity expression, I'm just going to put order quantity in its own column. And you know what? I'm going to put 2, the other element to this expression. There's order quantity and times the 2. I'm just going to put 2 as a constant in its own column as the factor. Let's just call it the factor. Okay. So order quantity times the factor resulted in that expression column increased quantity. Now we know that order quantity is an integer by looking at Object Explorer. The factor, what data type was that? Let's find out. I'd be curious to find out. Well, we can find that out using our SQL variant property function in the same way, so we'll do that. And the expression I'm trying to find out about is 2. And I'll call that column as 2 type, for want of a better word. So what does that actually tell us? Okay, the 2 type is an int. So what we're finding is order quantity, which is an int, the 2 factor, which is an int, that times that resulted in that, and that data type was an int. So an int multiplied by an int resulted in an int. Well, let's delve a little bit deeper into here, and instead of using ints, let's work with one of the decimal types of data types, and we'll work with, if we look in our table, there's a couple of money columns. There's unit price and there's unit price discount, both monies, and they are decimal types of data types. So let's investigate those. So I'm going to put those 2 at the front of the query. There we go. Now let's multiply the 2 of those, and then we'll investigate all the data types involved. Unit price times the discount as, call it discounted. Now, because there's a lot of 0 unit prices, the result is 0, because 0 times anything is 0. Okay. So what are the data types involved? Well, we know that unit price is money. We know that unit price discount is money. What is discounted? So let's just use our variant function again. We'll put in that expression. Call it discount type for want of something else. Okay. So that a money times that a money resulted in that which was a money. I think we're starting to see a bit of a pattern here. So let's see if we can compile some rules that we've found about how data conversion works. Well, first off, if you've got the same data types involved in an operation, the result will be that same data type. So let's save the file that we've been working on so far. So I'll go File, Save As, and I'm just going to call that my number query with SQL variant. Now I've already got it there, so I'll just overwrite it. We'll save that away. We may come back to it later. By all means, refer to it if you want to get back to the SQL variant property and see some examples of that. But let's just close that, and we'll come back to the my number query file that we saved at the previous lesson. So I'll just go File, Open, my number query, And there we go. It's come back to the basic query, and we'll make sure that you select AdventureWorks database, otherwise this isn't going to work at all. So we've come back to the basic query about order quantity times 2 as increased quantity. And you know what? I will just put order quantity on its own row there. And I'll tell you what, I'll just save that file. Now let's say our requirement is that we have to devise a column that is the order quantity, but instead of multiplying it by 2, we have to divide it by 2. We want to know what it is if we were to halve it. Let's say that the number that we're required to come up with is, if it's 1, we need to come up with a figure of 0.5. Let's assuming the type of good we're working with is divisible by 2. If it's 2, then it's got to be divided to 1, that sort of thing. Now that sounds fairly straightforward, but let's just do it and see what happens. So let's just call this expression order QTY divided by 2 as split underscore QTY and see what happens. Okay, there's our split quantity there. Now what's going on here, because there's some funny results here. If we look at the order quantity, that divided by 2 is, well, if it's 6, that ends up being 3. That sounds about right. If it's 2, it ends up being 1. If it's 4, it ends up being 2. That's great. But if it's 1, the order quantity is 1, the split amount is 0. Now that's not right. 1 divided by 2 is not 0. It's 0.5. Same with 3. If 3 divided by 2 is not 1, it's 1.5. What is happening? Well, what's happening is exactly what we saw in the previous exercise when we were working with a multiple of 2. What we're seeing is this is an integer. The factor that we're dividing by, number 2, the constant 2, that, as we saw in the previous exercise, is an integer. So if we do an operation involving an integer and an integer, what is the result, as we saw before, is an integer. And an integer is a whole number. It is not capable of expressing a decimal amount. That's what the other decimal data types are for. Now, when SQL Server arrives at that 0 value, it's actually truncating it. It's not even rounding it, it's truncating it, and truncation is rounding down. So it's always going to be 0, so even in terms of an approximation, it's not accurate. If, for example, that truly evaluated to say 0.9, it would still return 0. So it's not even accurate as an approximation. So what's our solution? Well, I'm going to show you one solution and then we'll discuss it. So I'm going to take my split factor here. I'm going to change that from 2 to 2.0, execute it and see what happens, and then we'll discuss it. Okay, what have we got? Split quantity has gone from a whole number result to a 6 decimal result. In the case of order quantity, dividing that by 2 gave us 0.5 and a whole bunch of zeros. That's pretty much it, 0.5, that's what we wanted. 3 divided by 2 give us 1.50000, and so on, and it's accurate to 6 decimal places. So what's happened? Well, this will become clear if we find out what exactly is the data type of this 2.0 constant that we've brought into the mix. Well, I've just typed in the SQL variant property function up there, and I'm asking it what is the base type of our little split factor 2.0 constant, and let's see what it tells us. It is data type numeric. So going back to our slide about the data types that can express decimal amounts, we came across the numeric. Now the numeric and decimal data types are constructed by passing in 2 values to the name of the data type. One is the precision and one is the scale. Now with that in mind, what is the actual data type of our split quantity that is the result of all this? Well, let's just try it. And call that our type. So a little split quantity there, what is its base type? Well, check that out. It's a numeric. So in this case, an operation involving an integer and a numeric resulted in a numeric. Well, let's go a little bit deeper and find out the precision and scale of this split quantity that we've produced. So I'm going to use variant property again. only this time I'm going to ask it what is the precision, and call that our precision, our P for short, and one is the scale, and our scale for short, and see what SQL Server tells us. Our precision and scale is, the precision is 12 and the scale is 6. So what are we seeing here? Well, what we're seeing is an example of data type precedence. Now, it's probably easier if I take you to the Microsoft documentation page about data type precedence. So we'll just go there. There it is. And it begins by discussing when an operator combines expressions of different data types, the data type with the lower precedence is first converted to the data type with the higher precedence. Now, it shows this precedence listed in that list down there. And if we look at the two data types we were working with, one is integer, there at number 16. The other one was numeric. Now remember, numeric is the same as decimal, and that's at number 12. So what's happened here is when it did that operation involving an int and a decimal, what it did was it converted, because that's number 16 and that's ranked higher, it converted the int to the decimal, and when you've got the decimal and a decimal in an operation, the result was a decimal. Okay, so now that we've got all this UViewed information about variant property, I'll get you to, if you like, save this in its own file for later reference. So I'll just save that as my number query with SQL variant. And but for the time being, we'll go back to our normal my number query. So I'll just get rid of all this SQL variant stuff, and I'll put it back to order quantity, the split quantity expression, increase quantity, order quantity, and star, and I'll just save that as my number query. And I'll run that. So what have we learned? We've got this operation involving an integer and decimal expression as the result. So how did we achieve that? Well, we had to, in order to get a decimal result, we had to either make sure either that was a decimal or that was a decimal. Now that we achieved by simply expressing it as a decimal. We just put a 2.0 on the end. So that's a fair solution. Now let's say, for example, that with our denominator there, if it wasn't a fixed value of 2.0, but it was instead some sort of a column. You know what, I'm just going to make up some sort of a column name here. I'll call it int. Let's say, I mean, there obviously isn't one, but let's say, for example, that there was an integer column somewhere on our table and we wanted to use that in our division operation. Now, when that was a constant value of 2.0, we could just express it as 0.0, that's a decimal, and that'll make sure that that ends up being calculated as a decimal. But when that's an int and that's an int, but we want a decimal, what do we do? How do we achieve that decimal? Well, that's when casting comes in, using the cast function to convert one or more or both of these values to a decimal, or the data type we want, in order to get the result we want. So we'll cover cast in a later lesson. So let's summarize what we've learned about data conversion so far. If you've got an operation and the members of that operation are the same data type, the result is that data type. If you've got different data types, SQL Server will convert one to the other based on precedence. Integers get converted to decimals, and I would refer you to that big list of the precedence chain, if you will, for further details. But in our example, if you've got an integer and a decimal, then the result will be a decimal.